I'm Don Machholz, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 18, for the week of May 6, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, May 6, the moon is 1 day short of full phase. Following full moon on May 7th, it will rise an hour later each night. Note how far south the moonrise occurs. Still some good photo opportunities. By the end of our week, Tuesday, May 12th, the gibbous, that is between full phase and quarter phase, moon passes 3 degrees south of Jupiter, then south of Saturn. Venus still hangs out in our evening sky, but not as high as it was. Do this. Take a quick look at Venus in comparison to the star Gamma Auriga, the star shared by both Taurus and Auriga. That star, Gamma Auriga, will be identified on Podcast 18, Star Map 1. You will see Venus approach this star, drift southward, then reverse direction, running away from that star. This will occur over about the next week and a half. In the morning sky, the moon will pass just south of Jupiter on May 12th. Will you be able to see the International Space Station this week? This depends upon where you live. North of about 40 degrees north latitude, you can see it in your morning sky, sometimes twice per morning. England, France, Germany, get up early. Between about 32 and 40 degrees north, there are limited viewing opportunities. In most cases, only near the end of the week will it begin appearing in your morning sky. That includes Japan and other areas in that latitude belt. From about 30 degrees north to 20 degrees south, nothing this week, no space station. South of about 20 degrees south, it is in your evening sky all week long. South America, the southern part of Africa, Australia, New Zealand, you'll see it in the evenings. To determine where it will be in your sky, you can go to the website heavens-above.com, enter your location, then click on ISS. Let's talk about comets. There has been some talk lately on the internet that maybe a comet is on its way to hit the Earth. That is not true. These rumors surface from time to time. During days like this, they seem to grow traction. Every time this rumor circulates, it depends upon one factor: secrecy among the scientists and political leaders. This cannot happen these days due to the nature of comet and asteroid discovery. There is no mystery as to how asteroids and comets are discovered, confirmed, and how their trajectories are determined. So this gives me a good opportunity to discuss to everyone how this is done. And as a comet hunter, I've had to become familiar with this process. When an astronomer, either professional or amateur, finds a comet or asteroid, they need to have it confirmed by others. This is how the process works. First, they publish the position. But one position does not determine the orbit or trajectory of the object. Astronomers need follow-up positions over several days. These positions are put into a computer program, and this computer program will generate the orbital elements. From this, something called the ephemeris is produced. It tells you where the object is headed. This usually takes a day or 2 or 3, and as more positions come in, the orbit is refined. And this is how it happens in practice. When a comet or asteroid is discovered, the date and time of discovery, the brightness, and the position are published on a public website. You can go to this website now. It is minorplanetcenter.net. That is minorplanetcenter, all one word, .net. This would be a good page to bookmark so you can come back to it from time to time. On the right side of the page, minorplanetcenter.net, you'll see the running statistics for discovered objects. We'll get back to that later. But now let's go to the headings up near the top, and there's one called Observers. You click on that, you get a drop-down menu, and we have a couple options here. One is NEO confirmation. NEO stands for Near Earth Object, and that's mainly for asteroids. And then you have another page called the Possible Comet Confirmation. NEO confirmation and possible comet confirmation. One's mainly for asteroids and the other is for comets. Let's click on one of them. NEO confirmation usually has more objects because there's more asteroids than comets found. And this is the discovery data for the asteroids and comets before anyone even knows where they are headed. Everything is here. Once one of these objects is first picked up, they are publicized on this website, and anybody can go to this website to see the objects. There's no secrets here. The astronomers who find these objects put them here because they're asking others to see the objects and get more positions so that they can get the object confirmed and an orbit can be determined. Now, as a visual comet discoverer, at this point, my job is mostly done. I have found an object, I have put it on the website, I've notified others, and at this point, others will take over and find the positions. Astronomers, both professionals and amateurs from all around the world, and most of them do not work for NASA, and politicians are not involved. They image or photograph these objects over the next few nights and thereby generate additional positions as the object slowly moves across the sky. They get these positions by measuring the location of the object on these images and converting it to something known as right ascension and declination. Those are measurements of position, and they publish them on the website. Now you can see these positions too. Click on the box to the left of any of these objects, then go near the top of the page and click on Generate Ephemerides. Then click on Get the Observations. There they are. The very first one is usually the discovery observation, and the following ones are quite often follow-up observations, and everyone can see them. Now, these observations are used to generate the orbital elements. And both professional and a good many amateur astronomers have computer programs to generate the ephemerides and predicted path for each and any of these objects. If any of these objects were predicted to come anywhere near the Earth, any one of the hundreds of astronomers would have the opportunity, the responsibility, and access to the public to announce this. All you need is a Twitter account, and you can start publishing this object is coming near the Earth. People would pay attention. If anyone withheld that information, someone else would come forward and announce it, because the hero of the story is the person who recognizes it and announces it. Now, there's no secrets here, and there's no reason to keep something like that a secret. After a significant number of positions are secured, An official designation is assigned by the Minor Planet Center, and the name is given to the object, and it can be seen under the heading Observers. Click on Observers on the upper left of the minorplanetcenter.net page, and you have a drop-down menu, and click on MPEC. Now read a few of these and see how they are announced. Generally, at the bottom of the announcements is a set of future positions. In particular, look at the delta column, DELTA. That is the distance in astronomical units of the object from the Earth. Now, an astronomical unit is the distance from the Earth to the Sun, or 93 million miles or 150 million kilometers. And a distance of, say, 0.2 or 0.2 astronomical units means 19 million miles or 30 million kilometers away from us, or 76 times farther from us than is the moon. There's no secrets here. Over time, this delta distance changes as the object and us move through space. By the way, the next column is called R, and that's the distance from the object to the sun in astronomical units. Let's get back to the main page for the Minor Planet Center. On the lower right, you have a table called Close Approaches. This table is continually being updated. These are objects that are expected to come within a few million miles of us. It gives us the closest approach to Earth, not in astronomical units, but in lunar distances known as LD. One lunar distance, the yardstick for measurement, is about 240,000 miles, or 385,000 kilometers. The moon might seem like it's close to us, and astronomically it is, but it does take 3 days to get there by spaceship. And if you could drive your car at 100 miles an hour between the Earth and the moon, at 100 miles an hour, it would take you 100 days to get to the moon. Now, if this table here, the close approaches table, says that an object would be, for instance, 0.8 lunar distances, or LDs, that object would pass us at a distance of 192,000 miles, or more than 300,000 kilometers. The Earth is a relatively small target in the large expanse of space. We are only about 8,000 miles across, or 13,000 kilometers, and the orbits of these objects are accurate. These objects are being tracked publicly, and they will not hit us. So you've learned how asteroids and comets are discovered and confirmed, how their orbits and future positions are determined, and now you know how you can access this information yourself. The website, once again, is minorplanetcenter.net. It's public and available to anyone with internet access. Since there's no secrets with the observations, ephemerides, and the orbits of these objects, there can be no conspiracy stating that only a few people know something that no one else knows. This simply cannot occur. Everything is public. Now for the comets that we can see this week. Use Podcast 17, Map 2, to locate 3 comets in our northern evening sky. That was last week's podcast, but it showed these comets for the next 2 weeks. The tick marks are for 0-hour universal time, and if you wait until a couple days after the May 7th full moon, then you will have some dark sky in the evening before moonrise to observe these comets. The brightest of the 3 continues to be Comet C-2019 Y1, known as Atlas. It is holding up well at about magnitude 7 to 8. It's visible in almost any telescope, and you can try seeing it in binoculars under dark sky conditions. And while you're looking at Comet Atlas, swing over to the next one less than 10 degrees away, because our next comet is Comet Pan-STARRS C/2017T2. It's holding steady at about magnitude 8. It reached its closest point to the Sun a few days ago, and now it's slowly moving away from the Sun and holding steady at about 150 million miles from us, or more than 1.5 times farther from us than is the Sun. Now, these first two comets will be around for a few more months. We'll get our last view of them in August. For these next two comets, however, we have limited viewing opportunities. In another month or month and a half, they will be gone. That brings us to Comet Atlas C/2019 Y4. This comet, as you might remember, brightened up rather rapidly and then it fragmented. It's still about 20 days from its closest point to the Sun, but it is in trouble. Since the nucleus fragmented, the comet has been dimming, and right now it's about 9th magnitude. However, as it nears the Sun, anything left would tend to brighten. So there's some theories that it will brighten a bit. The other theory is that because it fragmented, it's going to continue to fall apart and soon there'll be nothing left. So keep an eye on this one. That brings us to our last comet and our brightest comet. Comet SWAN C/2020 F8 reached unaided eye visibility at about magnitude 5 faster than expected. Up until now, it's been easily visible from the southern hemisphere. This week, those in the mid-northern latitudes will begin to see it in their eastern morning sky. Now, May 7th is full moon, and in the days following, the moon will be bright, but it will be in your western sky, while the comet will be in your eastern sky. The problem right now is not so much the moon's light, but morning twilight. With each passing morning, the comet moves northward and slightly higher in the sky. Podcast 18, Map 2, shows Comet SWAN's path for the next 2 weeks. So set the alarm, get out of bed, and look to the east. The comet has been sporting a long, narrow tail. That is called the ion tail, and it will be pointing up and to the right. See if you can detect the comet's tail rising before the head of the comet rises. Let's learn a new constellation. It is Corvus the Crow. It is identified and labeled on Podcast 18, Map 1, which you can get from my website. It's in the southern hemisphere, and the main pattern is made up of 5 stars, 4 prominent ones forming a quadrilateral. In fact, I used to run track in high school, and the pattern of these 4 stars looks like the marks made by the spikes of my track shoes. I used to think about that a lot when I probably should have been concentrating on my running. Between Corvus and Comet Berenices, which we'll discuss next, and continuing northward through the Big Dipper, we find many galaxies. They are visible to us because in this part of the sky, we're looking through very little of our own Milky Way. So our own dust and gas does not get in the way of us seeing the very distant galaxies. With the unaided eye, you'll see no galaxies and not even a lot of our own stars in the region. But do get out and learn Corvus, its distinct pattern, and its place in our southern springtime sky. By mid-July, it will be disappearing into our evening twilight sky. Learn the constellation Corvus. It's not enormous. It represents a crow, seen better from down below. From spring into the summer, then it's gone. What a bummer. Our binocular challenge for this week is a very large open star cluster. It's in the northern part of the constellation Comet Berenices and is called the Comet Berenices star cluster. It is identified on Podcast 18, Star Map 1, which you can download from my website. The cluster is made up of about 40 stars, and it's about 7 degrees across. Now, a pair of 7 by 50 binoculars will show most of the star cluster in a single field of view. The Comet Berenices star cluster is about 280 light years away from us, and the stars are related to each other and they move through space together. See if you can decipher any patterns made up of these stars. Some people see a V-shaped pattern pointed east. Our telescopic challenge for the week is the star Iota Cancer. This is a very nice double star. It's labeled on Podcast 18, Map 1. The separation between the two stars is 31 arcseconds, and the magnitudes are 4.0 and 6.6, so one is several times brighter than the other. The main star is orange in color, and the fainter one is white, although some people see the fainter one as being blue in contrast to the brighter orange star. So take a look at Iota Cancer high in your western sky as twilight descends this week. As I dove deeper into comet hunting in the late 1970s, I wanted my eyes to be in the best possible shape. So beginning in early 1976, I began eating a carrot or two each day. Then I discovered vitamin A, which came in a bottle, and each capsule was about 10,000 international units or IUs. I figured if one a day was good, then 2 or 3 per day would really keep my eyes in good shape. Not true. The daily recommended dose is 10,000 units or less, and I was taking too much. In fact, if you do take too much vitamin A, you can die from it. But maybe that is why when I got mononucleosis in October 1977, I also had jaundice and liver involvement. And the jaundice and the liver involvement was probably caused not by mononucleosis, but by taking too much vitamin A. I cut back on vitamin A after that, no permanent damage, and I don't take any supplemental vitamin A anymore. So this is a warning, don't overdose on vitamin A. However, I do take bilberry for my eyes. That's bilberry, B-I-L-B-E-R-R-Y. I do believe this has helped me to see better in the dark. Several companies make it, and it is okay to take as much as 1,000 milligrams per day. Astronomers, unless you're a solar astronomer, you do your work at night, and this can affect your sleep schedule. As a comet hunter, I remember one of my first morning comet hunting sessions where I first slept for 3 hours, did an hour of comet hunting in the morning, and then got 3 more hours of sleep. I was very sleepy the rest of the day, and I thought at the time it was not like I had 3 hours of sleep plus 3 hours of sleep for 6 hours. Seemed more like 3 minus 3 for 0 hours. In time, it got better. By the next year, most of my comet hunting was done after midnight in the morning sky. After my brother passed away in early March 1976, and I became depressed with insomnia and hyperactivity, a good combination for comet hunting, I was able to get by on less sleep. I soon found that on the nights I did morning comet hunting, I could and would get by on about 3 hours of sleep per night. I would get to sleep at 9 or 10 p.m., sleep 3 hours, get up at midnight or 1 a.m., drive to Loma Prieta, comet hunt, and then come home. In the summer, I would get home with only enough time for a short nap, perhaps only 30 minutes before getting up to go to work. In the winter, I would go straight from the mountain to work, change my observing clothes to my work clothes, then work all day. In the fall and spring, I had enough time to go home and shower, change clothes, and eat breakfast before going to work. After work, I would go home, do things around the house or some activity, eat, and go to bed at 9. I could do this for days at a time. A few notes. My sleep cycle was 90 minutes, which included a deep sleep mode. So 3 hours of sleep was 2 full cycles. I usually fell asleep within 10 minutes of lying down, so I set my alarm for 3 hours and 10 minutes hence, and it would wake me up when I was in the light part of my sleep cycle, and this made it easier to wake up. And those short naps in the morning after I arrived home, they were very deep sleep, lots of dreaming, and I could vividly remember those dreams upon waking up. I could do 3 hours of sleep per night for about 4 or 5 nights in a row. Then I needed a full night of sleep. Over the decades, that number crept down to 3, and then 2 nights in a row of 3 hours sleep before I needed a full night. If we had a spell of bad weather, and I watched TV and stayed up late instead of comet hunting, then I needed a full night's sleep. So it seems the comet hunting, especially the morning comet hunting, stimulated me through the day and allowed me to get by on so little sleep. Also, knowing that I had only 3 hours of sleep seemed to force me to go into a deep sleep and make the most of my 3 hours. I never used drugs, although I know at the time some people were taking drugs to keep them awake. I never did that. It wasn't without its effects. Sometimes I would get a headache and lose my appetite. My creativity suffered. My voice would become deeper, almost hoarse. My body temperature regulation did not work well, and sometimes I would heat up almost to the point of sweating. My sleepiest time each day was about 1 or 2 in the afternoon. If I powered through that, I would be fine for the rest of the day. And at the 21-hour mark, when I had been awake for 21 hours, I would begin to crash rather quickly. A few times, and this was especially in the evening, not morning comet hunting sessions, while comet hunting I would nod off and my head would slump forward and my right eyebrow would hit the eyepiece and that would hurt. It was quite a busy time of my life, wall-to-wall activity. I was in my mid-20s, then up into my 30s during those days. So how do you get up early in the morning without waking up those around you? Can you do it without using an alarm clock? I've heard from one comet discoverer that he drank a predetermined amount of water the night before, and this forced him to wake up and go to the bathroom very early in the morning at about the time he would have been awakened by his alarm clock. He would then go comet hunting. I had to handle even more sleep deprivation when my wife and I took care of my dad, who was confined to a wheelchair, from July 2016 until he passed away in January 2018. He simply had to ring a doorbell and I would be at his bedside within a minute. And that averaged 6 times a night. The typical range was from 2 to 12 times per night. I was also working 70 hours a week, so I needed my sleep, but it was lacking for those 18 months. My earlier comet hunting sleep schedule prepared me for this caregiving. Nowadays, I'm semi-retired and I can go back to bed after a morning session. I still find that when I get up and check the weather, if I'm on my feet for more than about 6 minutes, I'm much more likely to stay up and comet hunt than if I'm up for only a couple of minutes and then decide to lie down and get up in a few more minutes. As comet expert John Bortle once said about comet hunting, if you get to the point where the alarm sounds and you turn it off and go back to sleep, your comet hunting days are numbered. I never wanted to get to that point. I believe that if God gave me a clear, moonless morning, I should go out and make the best of it and not squander it. Or, as I used to say, I'd rather be sweeping than sleeping. You have been listening to Looking Up with Don, podcast episode 18 for May 6, 2020. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. And you can get all of the maps from this location. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what is going on in the sky, our weekly check on Comet Atlas and Comet SWAN as they ramp up in our morning sky, and I'll discuss something known as right ascension and declination, how astronomers know the position of an object in the sky. Thank you for listening. See the sky this week? I'll see you next week.